What are orbital maneuvers in space? Imagine you're steering a boat across a lake, adjusting your course to reach a specific spot. Spacecraft do something similar, but in a much more precise way. Orbital maneuvers are deliberate actions that change a satellite's path around a celestial body like Earth. These adjustments help satellites reach their mission goals, stay in the right position, or avoid collisions with other objects. Satellites in orbit follow paths determined by the laws of physics, especially Newton's laws of motion and gravity. Sometimes, these paths need to be changed intentionally. To do this, spacecraft use onboard propulsion systems, like thrusters or engines, which produce a force called delta V. This force changes the spacecraft's velocity and, consequently, its orbit. There are two main types of propulsion used for these maneuvers. The first is impulsive maneuvers, which are like quick bursts of speed. Think of it as pressing a button to give the spacecraft a sudden push. These are modeled as instant changes, even though in reality they take a few seconds. They are simple to plan and work well for most missions. The second type is low-thrust or non-impulsive maneuvers. These involve applying a small amount of thrust over a longer time, like slowly pushing a swing. Electric propulsion systems are often used for this, and they requiring more complex calculations because the change in velocity happens gradually. One common maneuver is called the Hohmann transfer. It helps move a satellite from one circular orbit to another more efficiently by performing two engine burns. The first burn puts the satellite into an elliptical transfer orbit, and the second burn circularizes the orbit at the new altitude. This method saves fuel and is often used for changing satellite orbits. Another important maneuver is station keeping. Satellites in geostationary orbit need to stay fixed over a point on Earth's surface. Small adjustments are made regularly to counteract gravitational pulls from the Moon and Sun, or other forces that can shift their position. Changing the inclination of an orbit involves tilting the satellite's path to match mission needs. This can be fuel-intensive because it requires a significant amount of energy to alter the tilt, but it's necessary for certain types of missions like polar orbits. Orbit raising or lowering is straightforward. Increasing altitude moves the satellite to a higher orbit, while decreasing altitude brings it closer to Earth. These adjustments are essential for tasks like scientific observation or communication coverage. Executing these maneuvers relies on understanding orbital mechanics, which are based on Newton's laws and Kepler's laws of planetary motion. These principles help scientists predict how a spacecraft will move and plan the most efficient way to change its path. In essence, orbital maneuvers are the controlled steps spacecraft take to stay on course, reach new destinations, or avoid hazards. They are vital for satellite operations, space exploration, and maintaining safety in the crowded space around Earth. Without these carefully planned actions, satellites could drift away from their intended paths or collide with other objects.